So our next presentation is about IPv6 Labs as a service and sort of the easy way to do hands-on training. The presenter is Christian Nelson with VMware, and I'm actually really excited to have him presenting because I sort of did the arm wrestling to get him to come and do this presentation for us here. He's doing some phenomenally interesting work at VMware, and I was really excited about the stuff he was doing with it, and I was like, you really need to tell other people about what's going on with it. So I hope you guys enjoy it. About Christian, 5 patents?
I think 5 or 6.
5 or 6 patents. So he's a smart guy. Got some interesting things that he's doing. For VMware, he's actually product integration now, product integration architect. So, and he gets to work on the networking team around building sort of resources for them for labs. So,
also, yeah.
And with that, I'll turn it over to you.
Thanks. Thanks a lot. Thanks. All right. Thanks a lot for the opportunity today to present you something very exciting. A project actually from VMware's engineering organization, which we call IPv6 Labs as a Service, or as the title says, our easy way to hands-on training. So I want to show you how we at IPv6 are actually putting IPv6 to work. I have reserved some time at the end of the presentation for questions, but if you have anything burning on your fingers right in between, just shout out. So as I'm new to this crowd, let's give a short introduction. Who am I? So my name is Christian Nelson. I work for VMware. My title is on there, but it's even so long it doesn't fit on the business card, so forget it. What I actually do is I'm basically the IPv6 enthusiast at VMware, and my role is around technical product management. So I have to listen, or I get to listen to customers, how they want to use IPv6 with VMware products on a daily basis, and then I go to engineering, and on a lucky day, they might actually listen to me and implement it. And if that's not challenging enough, I also have to cover certificate management. So based on your reaction, you probably never tried to change a certificate on a VMware product. That's pretty good for you. So in a previous life, I worked at Cisco and did actually something very different. I created a technology intelligence effort as part of corporate business development. So very different from what I'm doing right now at VMware. So before we dive into the presentation, I want to clarify a few things and set expectations right. So this presentation is going to be about VMware internal tools. So a very powerful concept that I think makes life at VMware much easier. It's not really about using IPv6 with VMware products. Also, I will give some examples at the end, but that's a completely different topic. So once this will actually work, once you can actually use IPv6 with VMware products, I might give a different presentation on this one. So with this, I would like to cover 4 things today. It's like, why do we actually care about IPv6 training for our staff? Then what do we need to do to actually make this happen? And how do we really make it happen with lots of duct tape or secret sauce, as some would call it? And then last but not least, demo time. So I'll actually show it how it looks for real. This is real, and this is not just like some theoretical stuff. So winter is coming. IPv6 is coming. Being in Silicon Valley sometimes does feel like King's Landing. And to be honest, our realization that we need to do something with IPv6 actually came through the federal IPv6 mandate. So I know that some people here at this conference were pushing really hard on the White House to accelerate IPv6 adoption, and I can tell you, you were successful. This really came back to us. So once we realized that we need to catch up, it became also clear that in order for our people to design, code, troubleshoot something, they actually need to know what it is. So we needed to provide some kind of way for training our people on IPv6. And what's better than giving them hands-on training, to actually letting them touch and feel the things. But how do you do this? How do you provide test beds and labs for engineers in minutes, not hours or even days? So a big thing is this whole X as a service nowadays, where everything comes as a service. Same thing here. How about we just provide labs as a service? Whenever you need it, you can get a lab on IPv6. Sounds pretty awesome. Very exciting. But what is it called when excitement has to make place for reality? IT. And in this case, reality hit pretty hard. And if you look actually at IPv6 in the typical large enterprises, it's somewhere between non-existent and lagging behind. So you see kind of like where I would place VMware. So we're actually working on it, and we're making a lot of progress. But it's certainly not at the place where you could actually roll out IPv6 throughout the company and provide IPv6 labs to every single employee like this. So we had to come up with a way to actually do this without IT enabling IPv6 toward the whole company. So another great approach is, let's have a look at what the other guys are doing. That's quite different from the approach that engineering organizations usually take of, not invented here, we have to reinvent it ourselves. In contrary to this one, actually the let's look at the other guys usually works pretty well. So in this case, what others were usually doing is physical labs or a whole bunch of machines under the desk that you could use for IPv6 labs. That didn't really fly for us. So we didn't really want to go for this. We wanted something that scales better and is much more agile. I do have to admit that we still have quite a large amount of physical labs, and we also have projects underway to enable these labs with IPv6, but more on this one later. So whenever you want to do something as a service, you kind of come up with the whole thing, hey, that's cloud. Perfect, so cloud to the rescue. And indeed, a lab in the cloud sounds very compelling. Look at all the benefits. Abstract resources, on-demand provisioning, scalability minutes, pay-per consumption, and efficiency of experts. That's almost too good to be true. But it actually works. And it has worked more or less for VMware for actually a few years. We use that at VMworld in the form of hands-on labs. But there are two things actually to it. So we don't charge, which admittedly is a big problem because we often internally run out of resources in our cloud because of that. I mean, it's free. You just take whatever you can. And sometimes everyone becomes an expert because of the not invented here syndrome. So sounds very cool. Let's throw in some IPv6 in our internal cloud. But not so fast. So first we have to step on the brakes again and ask this important question. Does the cloud actually support IPv6? So let's have a look at the main three vendors and VMware because, yeah, that's us. Turns out, no. None of them actually supports IPv6, at least not to a level that you could actually use it to build a cloud, to build an IPv6 lab in the cloud. So to give you an example with AWS, just to pick on the first one on the list, not explicitly this ones, you cannot actually assign an IPv6 address to a virtual machine inside of their cloud and expect it to communicate with another VM. They filter out this traffic. They only allow the IPv4 addresses that are assigned to this virtual machine. So that approach is not really going to work. But to make things even worse, these main cloud providers actually abstract away all the resources. That makes a lot of sense because you want to focus on the applications, or rather what the applications does. You don't want to focus on the low-level resources, or in this case, infrastructure. So as an example, in the typical clouds, the network that you get is some kind of layer 3 construct. But if we really want to build a lab for IPv6, we actually do want layer 2 connectivity because we want to try out things like DHCP v6 or Slack or all of these kind of things. So that doesn't really work. So to the rescue, how about a cloud that isn't actually that much of a cloud but shows us still a lot of low-level resources? So what that means is we actually need some kind of software-defined networking. I don't want to throw like too many buzzwords here. But what I mean with this is like we need the ability to create layer 2 segments. We need the ability to connect them together, or maybe not. Maybe we keep them isolated. And have then the different services or the virtual machines attached to each other. So lucky for us, we actually have a product like this. Again, it's like I don't want to sell you anything, but we had this around, which is called vCloud Director, and we also have a public cloud offering called, I think nowadays they call it vCloud Air, which is based on this product. And they use some kind of software-defined networking underneath, which is called NSX or VCNS. And we were even more lucky, we all had this in-house already. So we actually use one of our own products to build our own internal cloud, which in our case is called OneCloud. So it looks like we're done here and we can go and have a beer, but not quite yet. So we had to throw in a lot, and I mean a lot of secret sauce to actually make this work. And that's where I want to show you how we actually used our own product and made these IPv6 labs work in this environment. In the end, it's very simple, but extremely powerful. So our secret sauce in this case is a bit bubbly. What I mean with this is we create so-called bubbles inside of our cloud. What that means is inside of these bubbles, we actually capture multiple elements, which are in the form of virtual machines. These can be network elements, but can also be network-attached storage, servers, all these kind of things, as well as the network in between them, layer 2 networks. We then shield these components, or these bubbles, against other bubbles, so that we can have the same bubble a couple of times or different ones sitting right next to each other and nothing influence each other. It's kind of like the virtual machine concept one level higher. So taking multiple virtual machines and capturing them together. The other thing what we can do is we can apply a life cycle that is similar to what you know from a virtual machine to these bubbles. So we can create a bubble, capture it into a catalog, clone it, which means like duplicate it, deploy it from the catalog, and once we're done with it, discard it. And all of this usually takes a few seconds to minutes. So in our case, we call these bubbles VPod because it makes more sense than just calling it bubbles. And it's based on a product name which is called VApps. So to have a closer look at what this VPod actually looks like, the goal from a higher level was we wanted to mimic a customer environment in an isolated and replicatable fashion. So whatever a customer usually has as a site should be inside of this VPod so that we can then throw in our products and set up a test bed and just try out how this would look like. And this means, in this case, that we want to have everything that the customer usually has inside of there. So as an example, Active Directory, DNS, NTP, layer 2 segments, a router with network services such as DHCP, all of the things. And on top of this, we already wanted to have placeholders in place that you can just drop in your components, such as some kind of service, whatever it is. I'll actually give you a few examples in a second. So with this, our VPod is not really like a blank sheet that you start working on, but it's more like a form that is like, that gives you structure and that you start to fill out. So what you'll see here on the left side is actually our base VPod. So it's the bare minimum that you need to do something useful. In this case, we have a so-called VPod router, which is basically a Linux machine doing routing between the different layer 2 segments that we can have, and a jump host, which we call a control center. So it's a regular Windows 2008 or 2012 machine that also has all the services that you see listed up there. And to give you an example, these are actually screenshots live from our documentation internally, how these VPods look like and how they're pre-configured both with IPv4 and IPv6. So you see they already have a couple of layer 2 segments that are all pre-configured. As a user, you can use them or not. In the case of IPv6, we have one network segment that is configured for static-only IPv6, and then we have 2 segments that are configured for Slack, which have DHCP-v6 and RDNS for DNS. And we have 2 network segments that are configured for DHCP-v6. You'll see later why I set it up this way, that we really have like a pure stateful DHCP and something with like Slack. So these are typical deployments, but we did have a lot of trouble around this. Important is people can always change this. So by default, actually, people usually only use the first one with a static IPv6. Every single VPod has the same IPv4 and IPv6 addressing because we can take it and basically like replicate it, and they have nothing to do with each other. They're completely isolated. If you have a quick look at the prefixes that I have, as I use the ULA prefix, the FD53, to simulate kind of like an Anycast DNS. And then there's the prefix that I use for all of the labs. When I'm personally very disappointed, nobody ever noticed the little Easter egg that I put in there, because we call that whole thing is like dog fooding or extreme dog fooding. Well, you're the first ones. So to give you a real-life example of how a VPod looks like. So we have here a very simple example for a VPod, which is for vSphere, one of our products. It's basically bread and butter at VMware. So it's multiple ESX hosts or hypervisors, plus the vCenter, which manages these hypervisors, and then the network-attached storage, which provides iSCSI and NFS. And you see a couple of network segments in between. So in this case, 3 of them, one for management, one for NAS traffic, and one for vMotion, which is like this live migration of VMs in between. Again, it's like setting up something like this in real life and physical life usually takes between half a day and a day, and you can do tons of things with this. In our case, bringing a lab setup up and running like this, a few minutes, and you're good to go. So some more secret sauce in this one. Because the hypervisors that you see in the picture here, they actually run inside of a virtual machine. So you have a hypervisor running inside a virtual machine, which itself runs again on a hypervisor. So we call this nested virtualization, and it's extremely powerful. That's also one thing that you cannot do with any of these public clouds. And to be quite honest, this usually blows people's mind because they get completely confused in which VM and in what level and what hypervisor they end up being at. Here's another example, which is probably more interested for a networking crowd like you guys. So instead of throwing in the VMware products, how about we throw in some routers? So for example, the Cisco CSR 1000V, which is the iOS XE-based router, or Arista VEOS, which I've also done labs with. So with a setup like this, you can build all kinds of network setups. I, for example, built one myself with a couple of CSR 1000Vs in it and taught myself how to play around with BGP. Lots of fun. You can learn lots of things around it. Before mocking around with your real physical switches, we did some tests with VEOS inside of a virtual machine. And again, everything inside of it supports IPv6. So if you want to play around with OSPF v3 and see if it works or if it doesn't work with a certain vendor, if it comes in the virtual machine, we can throw it in there and try it out. So you're probably saying, hey, that's enough talking. I want to see how that actually looks like and how that works. Very good. So let's have a look at how this looks in real life. But I want to frame it in a little use case. So we have Emily here, and she's our very poor support engineer because she has to cover all the IPv6 support cases. And she has two cases that she needs to work on. The first one is a question, will vSphere, which is our hypervisor product, actually work with NFS or iSCSI over IPv6? And the second question is, can I use ESXi, which is our hypervisor, with stateful DHCP-v6? These are actually pretty simple questions. Unfortunately, she doesn't trust the documentation, which most of the time anyways doesn't really exist, and wants to try it out herself. So let's see if we can help Emily by using our labs and finding it out live. So the testbed that I want to use is actually the one that you saw before. So it's a very simple vSphere setup. We have the two ESX hosts, the control center, and the network attached storage. And in this case, in the catalog, in our internal catalog, there's already an IPv6 only setup. So once Emily checks out the setup from the catalog, she should be done. Just go in and verify if everything is up and running, because whoever set this one up, which actually was me, should have already configured it for IPv6 only with NFS and iSCSI setup over IPv6. And then the second use case, what we will do is, I showed you before that the testbeds already come with layer 2 segments that are enabled for stateful DHCP-v6. So all we need to do is attach an ESX host to that network segment and see what happens. On this one, spoiler alert, that one is actually really fun. Not so much for engineering, but at least for me from a product management perspective. So first, let's deploy a testbed to the catalog. So I want to show you how easy it is actually for an engineer in our organization, go into the catalog and deploy a new testbed. So what you'll do is you go into the catalog and actually start to deploy a new VPod from the catalog. In this case, I just type in IPv6 only and search for all the VPods that we have that are called IPv6 only. It will spit out two, one the previous version 5.1 and one the current version 5.5, which I'm going to pick for this example. And then I just click Next, give it a more useful name than the standard one. So I just call it IPv6 only. And I hit Next and deploy, and I have to wait a little bit. And after a little while, the whole pod comes up and is deployed. So you can see it's still deploying, but now it's done. So that's it. Now I have a testbed, and I can go in and play around with it. So how this looks like is I will actually go into this testbed, and I'll see all my resources. So there are my virtual machines and my network segments in between. Everything's powered off right now. It's not connected to the outside world, so that's important. I will actually now connect this VPod to the outside world. The reason why I would do this is either I want to reach from within the VPod to the outside world, like our intranet or the internet, in order to download software or upload log files or something like this. Or in the case that I want to use RDP or PC over IP to go into the VPod. So you'll see now I will power up this VPod, and you'll see in a second at the bottom you'll suddenly see this external network segment that is connected via this little blue circle to the internal VPod. And after a little while, all these virtual machines will suddenly come to life. So the black screens will suddenly turn into a blue screen, and they will be up and running. So that's it. At this point, I have a working IPv6 enabled vSphere setup, and I can actually go in there and play around with it and do some tests. So let's do exactly this. Let's start and have a look if our vSphere setup that I just brought up actually works with NFS or iSCSI over IPv6. So what I will do is I will connect to the control center. I do that by just clicking on this control center VM, which fires up a console. As an alternative, I could also connect via RDP or PC over IP, but for this demo, it just didn't look so nice if it would suddenly jump into another session. So I used the console. That's kind of like the same as sitting in front of a server and using the keyboard and the mouse and so on. So this is a Windows 2008 machine. I log into that machine. And what's good is it comes with all the tools that I need already installed. So I don't need to install anything on my desktop. In this case, I open the web browser in order to use the vSphere client, and I log into this machine. And now I can, with the vSphere web client, actually manage my vSphere setup. So I will drill down and have a look at the data stores that are currently configured. And while I drill down into the data source, I see that there are two already configured, one for iSCSI, one for NFS. And both are called IPv6, so it's pretty likely that they're configured by IPv6. So let's drill down into the iSCSI one and see who's actually presenting this iSCSI LAN and over what technology. And the more and more I drill down into this one, I will notice that this is actually served off a FreeNAS-based VM over IPv6 only. So you see there's an IPv6 only in the whole thing. Let's do the same thing for NFS. That's actually much easier to see and much more straightforward. So while I go into the LAN, I can see that this LAN is actually provided via an IPv6 address. So this LAN definitely lives on an IPv6 host. Just to make this whole demo complete and be sure that this is really using IPv6, let's have a look if this ESX host, these hypervisors, are actually configured in IPv6 only, as they claim to be. So I'm going to drill down into the configuration of the ESX hosts and have a look at the IP config on the interfaces. So looking here at the IP, at the interface configuration, I can see that all three interfaces that these hypervisors have an IPv6 address only. So we have the management, we have the NAS port, the storage part, which we're interested in, and we have the vMotion. All of that is running IPv6 only. So that setup is definitely running IPv6 only. What I didn't show you in this setup is there's actually a virtual machine running inside of this, which is alive, which is running without any issues. And just to confuse you a little bit more, so there's a virtual machine running on a hypervisor, which is itself in a virtual machine running on another hypervisor. So that's the point where people get completely confused. And that's why I didn't want to confuse you even more. So this setup definitely showed us that, hey, this works. The only problem is it's not supported by us. So don't try this at home. We do not support NFS or iSCSI over IPv6 in vSphere 5.5. But it's coming. So now let's have some fun with DHCP-v6 and ESXi. So we have an even more simpler setup in this case. So we have the base VPod that I showed you before with a control center and a VPod router. And we have one ESXi host that is connected to a DHCP-v6 enabled network. So what should happen is that box should just get an IP address via DHCP-v6 along with DNS information and the gateway information, and we should be able to use it. There's one issue with this. Out of the box, ESXi is not configured for DHCP-v6, so you actually have to configure it. So I already did this. But let's go into this virtual machine, into this ESXi hypervisor, and have a look how its network config is actually looking. So again, I open the console for this machine and I log in. And after I'm logged in, I will go and have a look at the IPv6 configuration of this host. Again, our expectation would be it should have gotten an IPv6 address and the gateway information. But as I drill down, I will see that machine got the IP address, but for some reason it didn't get a gateway information. So something is wrong here. And as a result, I'm also not able to ping the DNS server, which is in a completely different subnet. So there's something wrong. So let's have a look at the VPod router and try to find out what's going on here. I mean, I configured that box, so I'm pretty sure that the network is correct. So what I will do is I will fire up TCP dump and create a packet capture of that network that this ESX host is configured to and have a look if the network is correctly set up. So I'm going to start the network capture as you see here, let it run for a little while, capture a whole bunch of packets, then stop it, and then upload this packet capture to my machine. So that's one of the reasons why I wanted to connect it to the network. So as we do this, we can see the TCP dump in Wireshark, and we can actually see there's an RI message. So RI is configured. We have a whole bunch of DHCP-v6 packages going on the wire. So from a network perspective, that thing is configured completely correctly. So why didn't our ESXi host get gateway information? So I have a suspicion. If I actually go into the IPv6 configuration of an ESXi host, there's this little nice radio buttons down there that let me choose between no automatic configuration, so everything manual, where I have to fill out the IPv6 information down below, or I have the choice between either DHCP or autoconf or Slack. So what about if me not choosing autoconf actually means that the host completely ignores the RA messages? Maybe. So what if we would enable both DHCP-v6 and autoconf at the same time? That should work, except it's a radio button, so it doesn't let me actually do that. But there's always the CLI. So let's go into the CLI of the ESXi host, and let's try to enable both DHCP-v6 and Slack. So you see again here, we have these radio buttons. I can actually enable Slack via the graphical user interface, but I can definitely go into the CLI, which I'll do by enabling this support access, and then I can log into the host. So it looks like a regular Unix machine. And once I'm logged in, I can, via a command, enable the Slack or the autoconf on that same interface. So now if I go back to the graphical user interface and again have a look at the IPv6 network configuration, I can see, surprise, surprise, these two radio buttons are selected, which was not capable via the GUI. And now after restarting the IPv6 or the management network, I will notice that my host, there we go, I restart the network and have a look again at the IPv6 setup. And I can see now my host actually gets an IPv6 address via DHCP and it gets the gateway information. And as a result, if I now try to ping the DNS again, I can definitely ping the DNS without any issues. So now that host actually works as expected. So this bug is fixed, just to let you know. What's interesting is we found a whole bunch of issues, such as very basic ones like this one, once we actually made these kind of test beds available to our engineers. Because before it was very hard to actually get test beds up and running and test even basic things like this. The other things that it also showed is, sorry to say that, but DHCP-v6 or Slack, the whole address auto configuration in IPv6, it is very tricky. So I probably spent half of my time on issues around address auto configuration in a setup like this. So to summarize it, the VPod concept that we have here is extremely powerful for hands-on app and to train our engineers or even customers. We have additional offerings on top that I didn't show you, which make this even more streamlined. So for example, for our customers, we have a really nice web-based interface where they don't have to deploy these kind of labs from a catalog and whatever like this. They get a very simple thing, click on it, and boom, the whole thing shows up in their browser, and they can get started with instruction manuals on the right side. So that's something that everyone who wants to try out VMware products can use. Right now, none of the labs in there are enabled for IPv6, but it will come. The other thing is, like, I would say almost anything that you can dream of in IPv6, you can actually build inside of these VPods. We build all kinds of crazy things in there, ranging from load balancer over IPAM solutions, testing all kinds of things with IPv6. Also, a fun fact, I actually maintain this base VPod that I showed you earlier. And I enabled IPv6 in about a week. So it took me probably like an hour to actually configure the whole thing, and then the rest of the week to document it so that people can actually use it. So within a week, it was up and running. And this base VPod actually is used by VMworld for the VMworld Hands-on Labs. So anyone who goes to VMworld sees this Hands-on Labs where you can go and try out yourself, the products from VMware. Every single lab in there was IPv6 enabled under the cover. Nobody was using it because our products didn't support IPv6 at this point, but we basically deployed about, I think, 30,000 or 35,000 labs that were IPv6 enabled. And there was not a single issue with IPv6. Before this, we had people saying, oh my God, no, you have to disable IPv6. We cannot use it because it might create all kinds of problems. I proved 35,000 times that running dual stack is not a problem. It works without any issue. Then coming back on this whole physical test beds that I mentioned earlier, yeah, we also have them. And they're not running IPv6 yet. And actually, we're 9 months, it's September now, yeah, so we're 9 months delayed in getting them IPv6 ready. I mentioned earlier, we found a lot of bugs in our products, and we're fixing them. And then once our new release comes out that actually supports IPv6 much better, you will have under this URL that I have at the bottom here, labs that you can try out yourself. But what it really meant is like we were able to very quickly give our engineers hands-on training with IPv6. And we will basically embed it into the self-paced training that they have. I mean, in the past, all you would do, you point them to some kind of like online e-learning system for self-paced IPv6, which was good, but we all know that it's not that great. But actually then, in a second step, getting them into a VPod like this, where they can try out things themselves and actually can see the products working, or in this case, not working, changes quite a bit. So that's it from my side. Thanks a lot for your interest. And please let me know if you have any questions and comments. And I'm always eager to learn if you want to use IPv6 with our products and what your pain points are.
Questions? Someone's got to have a question for him, so.
Hi, I'm Brandon Ross with Network Utility Force. We've actually been using VMware for a bit to do a lot of this for our training classes and such, but we ran into some problems with the built-in virtual network interfaces. We think that maybe multicast doesn't quite work right all the time. It's been kind of intermittent and tough to track down, but we had problems with router advertisements and neighbor solicitation process working properly all the time. Did you run into any of that?
It depends on we have this, whatever you want to call it, this stack of different solutions. It depends on where in there your multicast or your Slack or whatever is not working. We had to put a lot of secret sauce in there, so I skipped over a couple things. I mentioned earlier that, for example, vCloud Air actually uses the same product. Unfortunately, you cannot replicate what I just showed you inside of vCloud Air, because some of that secret sauce that we were able to put into our own cloud is not in vCloud Air. And you might have running exactly into these kind of things. So if you catch me later, we might have a look, and it's usually like small things that you need to enable into your environment to enable this.
Other questions? I'm going to ask you a hard question.
Sure.
How come you're not using global unicast address space and routing out to public?
So the challenge here is that the VPods itself are not connected to the outside world. So everything inside of the VPod is encapsulated, and we take the same template and stamp it out multiple times with the same address space. So you would have, if you would have a global address, you would have the same prefix showing up multiple times, which you cannot do. And in our case, it's not possible to renumber them, because then a lot of the lab functionality breaks, where you want to train people having a certain setup. So it's actually one of the things which becomes much harder with IPv6. It's like, how do you do this? How do you stamp out multiple copies of the same template with the same exact addressing? In IPv4, you use NAT. I mean, you actually saw probably me creating NAT. With IPv6, that's not possible. So we actually had to use a proxy. If you want to go out to the internet via IPv6, you have to use a proxy. So we couldn't use ULA address on top of it. I was looking into using prefix delegation, which you could do, but again, it would break this whole idea that every single lab port is the same thing. So as an example, like VMworld, if we have customers running through the lab and you give them a lab manual, and then suddenly they see something completely different, it breaks this experience.
Interesting. Any other questions? No? All right. Well, folks, I think that now is the time to pack up and head upstairs and go socialize with other folks. So feel free, and if you, there might be enough time to sneak in a part of Chip's session. We can all crash on Chip and see what his live demo is like and see if we can cause him to sweat. Anyway, thank you very much for attending. Hopefully I will see you tomorrow. Remember, tomorrow actually starts at, I believe, 8:30 for the first session. So please join us at 8:30. It's earlier, and the registration is open in the morning. If you have colleagues who are showing up, tell them to show up at 8 o'clock for the registration portion. That way we can get our session started at 8:30 in the morning. Thanks so much, everyone. Enjoy.